Before I begin, I'd like to thank the Rework Organizing Committee for inviting us here today. My name is Adi Singh, and I'm a scientist at the Research and Advanced Engineering Wing at Ford, where I'm in charge of exploring software and system architecture that supports the company's work in IoT and in mobility. And these are two words you're going to hear quite a bit throughout my talk today, IoT and mobility. Because I believe that the technology is not advanced just for the sake of advancing technology. We advance technology so that we can enable ourselves to tackle real problems in the world, right? So that we can use the technology that we develop and make the lives of those around us better. So IoT, the Internet of Things, is the technology that we are exploring, or at least one of the technologies we are exploring, and mobility is the problem to which we are applying this technology. Right, so there is a lot of interplay between the two concepts when it comes to my work at Ford. Now, many of you may not know, but there is a fully operational, full-scale Ford research facility within 30 miles of where you guys are sitting right now. We are located in Palo Alto, right off the 280, where we inaugurated our Research and Innovation Center earlier this year. We're already a team of about 100 scientists, engineers, coders, designers, anthropologists, working together every single day to tackle some of the most pertinent problems in mobility that our generation faces. We conduct a plethora of research in topics like simulation, sensors, autonomous vehicles, connected devices, perception. We do work in connectivity. The OpenXC platform is a hardware-software solution developed by Ford and accessible to the public that gives users access to all the signals that are going around a car system at any given point of time. All the signals and data that define the state of a car. What's your engine temperature or engine RPM? What's your vehicle speed? How fast are you accelerating? What's your steering wheel angle? How far your windows are rolled up? Or what's the configuration of every single knob on your dashboard? Data that characterizes how a car is being used at a given point of time. We call it characteristic data. And we expose the characteristic data of a vehicle to you so that you can build your own apps on top of this data, sort of a car API, so that you can enhance and customize the functionality of your car. And to really put this in perspective, consider your smartphone. Your phone exposes a bunch of characteristic data about the phone to you. How are you tilting the phone, or what the GPS coordinates of the phone are, or where the user is tapping on the screen or touching the screen, or whether the user is tapping or sliding, so on and so forth. And look how that has changed, that has transformed the function of a phone. Today there are hundreds and thousands of apps that you can download onto your smartphone that have enhanced its functionality from just a device used to make a call. We want to usher a similar revolution in cars. And the OpenXC platform is our first step in realizing that dream. And I want you to imagine, just imagine how different your life would be if you are able to download apps for your cars, just the same way you download apps for your phone these days. Our labs are doing work in the Internet of Things. What happens when you take a car and transform it from an engine on four wheels to a device that is able to communicate with your smartphone, your smartwatch, your smart house, your smart hoverboard, any device on the Internet of Things universe. What are the applications of taking the car and putting it on the cloud? Metaphorically speaking, that is. More importantly, what are the implications of doing so? Now, that's all part of our research scope. Can we connect your Nest thermostat, for instance, to your car so that when you pull into your driveway, your house is exactly at the temperature that you find convenient? Can we connect your Jawbone or any other fitness tracker to your car and correlate your biometrics with your driving style? Can we then use this data to come up with heuristics about whether you're tired or whether you're sleepy or whether you're drowsy, whether you should be driving? Right, so a lot of the work that is coming out of our innovation center in Palo Alto is really spearheading Ford's work in IoT and in connected devices and mobility. Which brings me to a question that I'm most often asked. when I talk about Ford in the Valley. What is a company like Ford doing in mobility? Why are we in mobility? Why is Ford interested in mobility? The short answer to that is we are spearheading the mobility movement. You see, at Ford, we realize that unless we transform from a traditional automotive manufacturer, just a company that is interested in building cars, to a mobility company, a company that wants to understand how people move, how vehicles move, how people and vehicles interact in different environments. Unless we model that, unless we see what problems they face and understand them and then try to fix them, we will cease to remain as influential a force as we have been in the last 112 years of our existence. And to put this in historical perspective, indulge me a little, This is not the first time in history that Ford has taken upon itself to solve problems in mobility. About 100 years ago, we created the Model T, an invention that essentially reduced cars from a rich man's plaything to a common man's everyday tool, right? That was Ford enabling mobility for the common American. Let's talk about something else. About 80 years ago, the most pertinent problem in mobility facing the country was not that we did not have enough cars, but that we didn't have good places to drive them on. What are you going to do with cars when you don't have any places to drive them on? And it was under the leadership and lobbying efforts of Ford and GM that the government of President Eisenhower undertook the largest civil infrastructure project ever initiated in the history of mankind. The United States Interstate Highway Project. Now you and I, we take roads for granted these days, but think how your life would have been different if we did not have a robust network of roads connecting the country. That takes foresight. Apart from companies being able to send their goods around, more cheaply and faster, it gave rise to a commuting workforce. People didn't have to live right next to their offices or their factories anymore. A commuting workforce gave rise to pockets of societies all along freeways, which were the founding stones of what we today know as American suburbia, something that defines America. At the intersection of major freeways, minor settlements became large cities, Dallas, Texas being a famous example. That was Ford literally sculpting the landscape of America through its contributions in mobility. And we hope, indeed, we are certain that as we take it upon ourselves to tackle a new set of mobility challenges faced by a new generation of commuters on the road, that our efforts and our research and our solutions will have an effect of equal magnitude, if not greater, in the years and the decades to come. Now, let's approach this from another angle. You and I, we experience streets of California every day. The San Francisco Bay Area, to be specific. The San Francisco Bay Area has a population density of about 1,800 people per square mile. Get into San Francisco City, and you have a population density of 12,000 people per square mile. And already we are facing insurmountable problems in traffic congestion, in traffic collisions, in gridlocks, in parking. Right before me, Steve was talking so much about parking problems in the city, right? Today morning, it took me half an hour to drive 3 blocks to this place. And some would still say that I got lucky, right? Now, what happens when you move to even more extreme environments? The streets of Mumbai cater to a population density of 54,000 people per square mile. Now, I want you to listen to that, 54,000 people per square mile. How is mobility perceived in such scenarios, in such environments? What problems become magnified? Which ones are diminished? Which ones should you focus on? More importantly, what solutions can we introduce that most efficiently enhance the experience of movement, the experience of locomotion for people living in such extreme environments? As a global company, Ford is interested as much in solving mobility problems on the streets of Mumbai as we are interested in solving those on the streets of California. Which is why earlier this year we announced 25 grand mobility experiments happening all over the world aimed at studying mobility in varied demographics. We want to understand via these experiments how mobility, how the perception of mobility, how the concept of mobility changes in different environments, infrastructures, and what problems are faced by people in these different environments, and what we can do in solving these problems. Now, under the fourth Smart Mobility Program, these experiments are vast, both in terms of scope and in terms of geography. Instead of giving you a laundry list, I'll give you an example. In Atlanta and London, we are exploring parking solutions. In Dearborn and in New York, we are exploring dynamic social shuttle buses. In Germany and in India, we are researching efficient car sharing models. How can we efficiently allow a small community to share a car? In West Africa, in the Gambia, we are looking into healthcare. How can we make mobile healthcare more accessible? So really vast in terms of scope and in terms of geography and in terms of ambition. But the one experiment that I want to really focus on for the remainder of my talk is the one happening closest to you guys, the InfoCycle Project. Coming straight out of our, that is absolutely wrong. That is correct. The InfoCycle Project. Now, this is coming straight out of our labs in Palo Alto. The InfoCycle Project is consider it a sensor-rich connected platform that aims to study how bikes move, how bikes interact, how bikes behave in an environment that is both dominated by and built for cars. Now, we want to understand, we at Ford love cars, but we do embrace other modes of transportation, and we want to see how we can use bikes as part of multimodal solutions to urban mobility problems. Now, why bikes? The answer is simply a growing trend of bike usage across the country. In the last 20 years, San Francisco has experienced a bike usage increase of over 300%. In Portland, Oregon, this number has been over 400%. And in Washington, D.C., on the East Coast, this number has been close to 500%. These are big numbers. You can't ignore them. We can't ignore them, especially when they happen in a country like America, which has one of the poorest biking infrastructures in the developed world. No, we don't want to ignore these trends. We want to cater to these trends. We want to encourage these environment-friendly solutions to personal transportation. In fact, we want to see how we can assist as a company in transforming bikes into an integral part of a multimodal platform that most effectively, that most efficiently tackles problems in city mobility. And this project really started off in our labs last year with us connecting a few sensors to bikes to characterize their usage. And as our project has evolved, we have developed our Gen1 Prototype, which is a sensor suite designed to augment traditional sensing bike sensing data like pedal count or RPM or pedal speed with more subtle data like humidity, lighting conditions, temperature, pressure, GPS coordinates, 9-axis IMU parameters, to really give us a holistic view of how bikes are being used in different places. The Gen1 box, it slips into a jacket that is strapped to your bike. You switch it on, it connects to your phone via Bluetooth, which then streams your data onto our cloud. And then our team of data scientists are able to access this data to create a holistic model, to create data-driven models of how bikes are being used and what problems they face in different sub-environments. Right? So this nifty little box was shipped out for user testing earlier this year. And one thing we realized after the first phase of user feedback came back was that people did not want a clunky data logger attached to their bike. How are you going to do about that? So we took that user feedback. We went back to our drawing board. And in a matter of a few months, we took this and we reduced it to this. Our Gen2 Prototype has the same communication and data logging capabilities as our Gen1 box, while coming in a package size that's almost 20 times smaller. And the reason I'm showing this to you is to drive a point. and that is the adoption of user-centric design processes by our team under the Ford Smart Mobility program. We are putting users at the center of every single ideation process, every single design, prototyping, testing process, so that we can bring to users products that they would like to have, products that they would want to use, products that effectively meet their needs, products that enhance their experience as opposed to obstruct it. That is the philosophy of user-centric design. And this here is the evidence of it. So a lot of the work that is really coming out of our labs in Palo Alto, I'd say, is really driving forward the future of innovation within Ford. And not only within Ford, but within the broader context of the automotive and the transportation industries. And looking at the future, we do not know if our work in connected devices or the Internet of Things or any of the mobility experiments is going to yield a single dedicated solution. But what we do know is that we will learn something from every single one of these experiments. And that learning is what is important to us. That is what we focus on. That is what we emphasize, because it is this learning that is really going to shape the approaches that Ford takes as a company as it goes on to define automotive technology and mobility at a global scale in the years to come. Right, and that is all I have to say about this. So, Florian, Sol, thank you.
Okay, thank you very much.